It's also helpful at this point to again look at predicting ionic charges, because the charge of the ion comes into play when we are naming these things, and particularly how they bind together and how we represent them with a chemical formula. So if we have group 1A, they will have a +1 charge. Group 2A has a +2 charge. Group 3A will have a +3 charge. If we now look at group 7A, they have a -1 charge. Group 6A has a -2 charge, and group 5A has a -3 charge. In the group 6A, there's an exception, and the exception here is peroxides, which will have a -1 charge. Notice that we skipped group 4. The group 4 complexes will generally form molecular compounds, which is the next, which we'll discuss a little bit later. Okay. In addition to the binary compounds, we need to look at nomenclature for transition metal complexes. So for transition metal, or for transition metals, we need to include extra information. And this quote-unquote extra information is going to be Roman numerals. And these indicate the charge of the transition metal cation. So, for example, there are two forms of copper oxide. So copper oxide exists as CuO and Cu2O. The question is, what is the difference between each of these? The oxide part, or the oxygen, is going to have a -2 charge. So the question is, what's the charge of each of these coppers in this particular complex? If it's CuO, that means the copper has to have a +2 charge, or it's a +2 cation. For Cu2O, this is going to have a +1 charge. So if we go to name each of these, the first copper oxide is going to be copper 2 oxide, and this Roman numeral indicates the charge of the copper ion. Cu2O is going to be copper 1 oxide. So with these transition metals, they exist in varying oxidation states, or with varying charges, so we need to indicate that in parentheses to distinguish between CuO and Cu2O. Other examples, if we were given the name and then went to a formula, if we were given iron 3 bromide, iron 3 bromide has a +3 charge on the iron. The bromide is in group 7A, so it's going to have a -1 charge. So this has to be FeBr3 in order for the charges to cancel out. If we also looked at titanium 4 sulfide, the titanium is going to have a +4 charge. The sulfur is in group 6A, which gives us a -2 charge, so that's going to be TiS2. So this is the way that if we have binary complexes where you have a cation and an anion, this is how we would name each of them, and this is the thought process we go through if we've already determined that we have an ionic compound.